Now let's do the same for the function g of x. Firstly, take a look at vertical asymptote. We see that the denominator x squared plus 1 square root is never 0, so that means the function g of x is defined everywhere, which means it's going to be continuous as an elementary function, so no vertical asymptotes. Since g of x is defined everywhere, it is continuous as a elementary function. So there is no vertical asymptote. And then we can take a look at horizontal asymptote by simply taking the limit as x goes to both infinities. So let's take a look at positive infinity. Limit x goes to positive infinity of g of x. We're going to have limit of 2x divided by x squared plus 1. So what happened is that both the numerator and the denominator go to infinity. So we need to kind of factor something out from the denominator to cancel with the numerator x, so we may have a finite value as a limit. So what we do here is we're gonna factor x squared from the inside square root, so write it as that 1 plus 1 divided by x squared. And then we're gonna distribute this square root to over the product. So that's gonna give us square root x squared times square root 1 plus 1 divided by x squared. And there is a formula for us to convert the square root function, square root of x squared. That is square root x squared is equal to absolute value of x, right? And then we can remove the absolute value sign, the bar, according to where x is approaching. If it's approaching positive infinity, then we know x is positive, so removing it without changing anything. Otherwise, if x approaches negative infinity, we place an extra negative sign in front of it. Okay, so let's be more complete. This is equal to x if x is greater than 0, negative x if x is less than 0. Okay, so because x approaches positive infinity, so now we can remove the absolute value without changing anything, which is just 2x divided by this x times 1 plus this. So we cancel, right? And now we can plug in sort of infinity. X approaches infinity, 1 divided by x squared is going to approach 0, as the denominator is going to get infinitely large. So what we have in this expression is 2 divided by square root of 1 plus 0, which is going to be 2. Okay, so that tells us, what does that mean? That tells us y equal to 2 is a horizontal asymptote, because we have a limit to be a finite value. But that's not finished yet, because we still need to check x, the limit as x approaches negative infinity. So let's just erase the symbol, and then we will just change the sign to do the calculation. can calculate limit as x approaches negative infinity. Right? All the steps, all the cancellation is going to be the same. Right? These things still apply until this point. Because when x approaches negative infinity, we have x less than 0. When x is less than 0, the absolute value of x is now replaced with negative of x instead of just x. So we're going to have, instead of this, we have negative of x. The x approaches this because absolute value is converted differently here. But we still cancel, right? Still cancel this x with this x. That will leave us with limit x goes to negative infinity 2 divided by negative of 1 plus x squared, right? Still, the x1 over x squared still approaches 0 as x goes to negative infinity. So this is gonna evaluates to be 2 divided by negative of 1 plus 0, which gives us negative 2 instead of positive 2. So kind of a slight change of the final value there. Since that is a even number, so that I'm going to conclude y equals negative 2 is also a horizontal asymptote. So in fact, we have two different horizontal asymptotes, one being y equals negative 2, the other one is y equals 2. And then we don't have any vertical asymptotes.